Okay, y'all, today we're going to take a look at if a factor given is indeed a factor of a polynomial. There's two ways you can do this. The first way is you can naturally take the polynomial and divide it by the factor. And if it has a remainder of 0, then it is a factor. If it has a remainder of anything other than 0, then it is not a factor. However, there is a thing called a factor theorem. And the factor theorem tells us that a polynomial f of x has a factor of x minus k if and only if f of k is equal to 0. Meaning, if you were to take this factor, make it equal to 0, solve for x, whatever x value is, when you plug it into f of x, the polynomial, if it gets a 0, then it is a factor. So let's take a look on example number 5. Is x minus 2 so a factor of the polynomial x squared plus 2x minus 4? What I could do is I could make x minus 2 equals to 0, solve for x, so that means that x is equal to positive 2. Now that I know what x is, I'm going to take this 2, plug it into the x's of my polynomial. So that's going to give me 2 squared plus 2 times 2 minus 4. And I want to know if that is indeed equal to 0. So that's going to give me 2 squared is 4, plus 4, because 2 plus 2 is 4. That's like 2 times 2 is 4, minus 4. Is that going to give me 0? 4 plus 4 is 8. 8 minus 4 is 4. So 4 is not equal to 0. Therefore, x minus 2 is not a factor of x squared plus 2x minus 4. Now, if you take a look at another one, let's take a look at one that possibly is a factor. Look at part B. Is x plus 5 a factor of this big polynomial? Same deal. Make x plus 5 equals to 0. So x is equal to negative 5. Plugging that in, you have 3 times negative 5 to the 4th power plus 15 times negative 5 to the 3rd power minus negative 5 squared plus 25. And I want to know if that is equal to 0. So let's check. Negative 5 times negative 5 is positive 25. 25 times 25 is 625. So that's 3 times 625 plus negative 5 times negative 5 is 25. 25 times negative 5 is negative 125. So plus 15 times negative 125 minus negative 5 times negative 5 is 25 plus 25. Okay? So you have 3 times 625. That's going to give you 1,875. This is going to be minus because positive times a negative, but 15 times negative 125, working on this on the calculator, I got 1,875 right here, minus 25 plus 25. This is going to zero out. This is going to zero out. So indeed, this is 0 is equal to 0. Therefore, x plus 5 is a factor of 3x to the 4th power plus 15x to the 3rd minus x squared plus 25. Because when you plugged in the x value from the factor, you get a 0. Now that we know if something is a factor or not, we can now determine that before trying to factor a polynomial completely out. So let's take a look at the bottom, example number 6 right here. There's two things that they're asking you to do. One, they're asking you to show that x plus 3 is a factor of this polynomial. So that's part 1. after you show that, if it is, then factor f of x, this polynomial, completely. Well, instead of just blindly going in and trying to factor it and see if it works, we're going to make sure that it works first. So x plus 3 equals 0. X equals to negative 3. Well, let's double check. X to the 4th power, so negative 3 to the 4th power, plus 3 times negative 3 to the 3rd power, minus negative 3 minus 3. I want to see if that is equal to 0. 3 times 3 is 9. 9 times 9 is 81. So negative 3 to the 4th power is 81. Plus 3 times negative 3 times negative 3 is 9. 9 times negative 3 is negative 27. Plus 3 minus 3. So this is going to be 81 minus 81 plus 3 minus 3. Is that equals to 0? Well, I know that this cancels out and this cancels out. So this is going to give me 0 equals to 0. So yes, this is a factor. And because yes, it is a factor, I can now factor it completely. This is a factor I'm trying to factor. X to the 4th plus 3x cubed minus x minus 3. Because there are 4 terms in this factor, 4 terms means that I'm going to try grouping, factor by grouping, just like what we did earlier last week. So let's see. I am going to group these 4 terms so that I'm grouping the first 2 terms and the last 2 terms, trying to find the greatest common factor of each of those groups. Greatest common factor for the first 2 terms is x to the 3rd power. So when I factor that out, I'm going to get x to the 3rd times x plus 3. Use a different color. X plus 3. Okay, for the second term, I have no greatest common factor when it comes to number, but I notice that it started with a negative. So I'm going to factor out a negative 1. So I have minus 1 times x plus 3. I'm going to divide out the negative 1. So now if I'm looking at these 2 terms right here, the first term is x cubed times x plus 3. The second term is 1 minus 1 times x plus 3. Both of these terms has x plus 3 in common. So I'm going to factor out my x plus 3 right here. Factor out my x plus 3. So I'm going to get x plus 3 times, what's left over? X cubed minus 1. Now normally I would say, hey, this is it. I'm done. However, if you take a look, you got x cubed, that's a perfect cube, minus 1. 1 is also a perfect cube. So I have a cubed minus b cubed. Now, go back to the last lesson. You have a special factor pattern that says difference of 2 cubes. So you're looking at this formula right here. You're looking at a cubed minus b cubed times a square plus ab plus b square. And this is what a difference of cube is going to factor into. That means that I can take this and factor it into those 2 factors. Let's see. My a is my x, my b is my 1. So when I factor it, not a cube, this should just say a minus b. So a minus b, it gives me x minus b is 1, so x minus 1. A square, that's my x square, plus AB plus x times 1 is 1x plus b squared plus b is 1. 1 squared is 1. So x cubed minus 1 is going to factor it into x minus 1 times x squared plus x plus 1. And finally, but don't forget, we still have that x plus 3 that we need to pull down. So pull that down, bring it out in front. We have now completely factored out the polynomial that was given. Final answer right there.